Hi everyone, I am Akhil Kovuru. Today I will be presenting on the paper titled Software Aging by David Lodge Partners. The author of the paper is David Lodge Partners. His areas of interest were in software design, documentation, and quality assurance. He has an H-index of 60, and this journal was presented on the 16th International Conference on Software Engineering. This paper has been cited 1791 times. So, software aging. As the name suggests, the software do age. That is, they do get old, just like us human beings. Yes, that's true. The software aging is inevitable, but there are steps that, if we can follow, can reduce or slow down the process. As I said, aging is inevitable. We can't stop the software from getting old, but we can only understand the causes or take steps to limit the effects, temporarily reverse some of the damages caused, or prepare for the day when the software dies, that is, it is no longer available. As I said before, software aging is inevitable. The only thing we can do is to be ready and prepare for the consequences. Next comes the research questions. Coming to the research questions, this paper basically finds out like what are the causes for software aging and what approaches can be followed to limit the software aging. The problem that we have today is that most of the software products they get old. That is, the software gets outdated. This research, particularly the on software aging, is very much helpful and is very much needed because we can know exactly what are the reasons that cause software aging, and also we can know how to tackle this and what steps needed to be followed to limit these effects. And at the end of the day, by following these approaches, we can only delay the software aging process, and also we can be prepared for the situations when the software gets old. So now let's discuss about the different causes for software aging. uh, in this paper, the author has mentioned two main reasons for the software aging. The first one is the failure of the product owner to adapt to the present day needs. The software owners or the software product owners are not willing or are not changing their software or upgrading their software to the present day needs. As a result of this, the software gets outdated, and this software will not be used by anyone. Since the product owners are not updating their software, the older versions of the software will no longer be used by any of the customers, and the software gets aged even though the customers are not using it. Coming to the second reason, it is upgrading the software. Now you people might be thinking how the software gets older or outdated even if we change. There are again many factors behind this. The first one is the changes are made by the inefficient developers. Here, whatever the changes that are made by the developers, they do not have sufficient knowledge or do not understand the original design concept. So when developers like these makes any changes, these changes will not be consistent with the original design, and as a result of this, the differences in the design and the code, the changes will be the changes that are made by the developers will introduce the bugs and makes the software even worse. The second reason is like multiple developers changing the code. Here in this case, multiple developers will be working on the same similar software thing, and they will be changing the code. After changes, these developers should know the both original design rules and the exceptions made to the rules as a result of the changes. Otherwise, both the original designers and the other developers who have changed the software will not understand the functionality of the changed product. And the last one is because of proper lack of proper documentation. When that is like when developers change something, the change has to be properly documented. Otherwise, making any changes further will be difficult. We will be clearly uh, talking about this documentation in the coming slides. And so these two are the main causes for software aging. So either way, the software gets old if not done correctly. Okay, so let's discuss about the effects of software aging. The first effect of software aging is the inability to keep up the product in the market. As discussed in the previous slide, because of software aging, the customers no longer use the software as they find better products in the market. So the first and foremost effect of software aging would be the product will lose customers, and the software grows bigger as it ages. This is because to add any new features, the developers add new code instead of modifying the existing code. As said earlier, the developers do not understand the original design rules, and also because of lack of proper documentation, they add new code instead of modifying the code. As a result of this, the developers take time to add new features, and customers move on to the products which they feel feasible and which meets the needs of the present market. And the second effect is performance issues. Um, as the developers add new features which alters the original design, the performance reduces. Whatever the changes that are made by the developers is in turn related to the performance. And the third effect of software aging would be reliability. As the developers do not understand the software well, all the changes made to the code results in errors and bugs. Changing one bug will bring two bugs. This 1-2 punch will lead in increase of bugs and thereby decreasing the reliability of the software. Okay, so what actions are needed to limit the effects caused by the software aging? The first approach or the first action would be the design for success. The first step in this process is to apply the slogan design for change. Design for change is nothing but any designer or developer has to design the product assuming or predicting the changes that can likely to happen in the future even before the software is implemented. All the changes cannot be predicted at once, like beforehand, but we can predict some of the changes that may happen in the future, like replacing a terminal, or changes in the user interfaces, or moving to a new windowing system. These are some of the changes that we can predict beforehand. Then once predicting these changes, the developers has to make sure that at least these changes that happen in the future are confined to small sections of the code. So if at all any changes occurs in the future, only these small sections of the code will be affected without disturbing the other modules. Following this approach, that is design for change, is designing for success. It is as simple as that. Again, the author has mentioned several factors or reasons why this approach is not being followed in the current software systems. You can find those things in the paper. And the second action that can be used to limit the effect of software aging is having a proper documentation. One major problem in the software industry is the original designers who develop the project will not be working continuously in the same project. So the new developers who come into the project do not know how the software has been designed, or do not know about the original design of the software, intention of the software. And moreover, the design principles or any design changes are not properly recorded, which makes life tough for this new developers to maintain the software in future. And even if there is a proper documentation, it will not be in sync. It is in with the changes that might have happened over the period of time. It might be poorly organized, and the design document and the documentation would be inaccurate. And if at all, if it is of this kind, the document is completely useless for the maintainers. The author has emphasized more on the documentation, and which is rightly so, because most of the times the developers neglect the documentation, keeping the deadlines or the releases in mind, and do not think about the consequences that can happen later. So concentrating on these deadlines and releases can bring short-term success, but as the software ages, the cost increases into multifolds in repairing the product. So proper documentation has to be there to reduce the or to limit the effects of the software aging. And the third action that we can follow to limit the effect of software aging would be reviews. Here, reviews are nothing but the second opinions, and these second opinions are always helpful. A proper review of a design has to be done even before the coding gets started, and again these reviews has to be done by the people who have knowledge in this area. A proper review can bring out the issues that the designers miss initially and can be tackled accordingly. And again, every software product that is designed in such a way that it serves for years, and to have that reviews play an important role, and everyone has to take these reviews seriously. So these are some of the measures that need to be followed for the software products which are aged already. So the first measure is stopping deterioration. The first step is to slow down the deterioration by recreating the structure or the design whenever the changes are made. And a proper review has to be done to ensure that the changes are in place with the original design. And here record different versions of the code, because all the changes that are made by the developers, there might be many versions of that code. So all these differences in the different versions of the code should be recorded and maintained. New documents should be created and reviewed. The code and the changes made in the code has to be in sync with these design documents. And the second measure is retroactive documentation. As discussed in the previous slide, that a proper documentation is very helpful and can limit the effects of software aging. So a proper documentation will only improve the software and will limit the effects of the software aging. The third measure is retroactive incremental modularization. Modularization is nothing but having nothing but the code that can have changes in the future is put together in a single module. So in other words, the code in each of these modules will have a specific functionality. So whenever changes have to made to the specific functionality, only that particular module can be modified without affecting other modules. Thereby, as a result of this, the chance of introducing bugs because of these changes will also reduce. And the final measure is amputation. This is a controversial this measure is a controversial one, because removing the sections of the code which are not useful or which has been modified many times, and still if there is a problem with that particular section of the code, we need to remove that particular section of the code. And if we need to replace that particular section of the code with stumps which perform the same functionality and can be implemented to prevent this aging. As I said, this is a controversial decision because the original developers who might have written the code may not agree in removing this particular section of code. Coming to the planning some of the things can help in reducing the effects of software aging. We should always plan ahead for software development. The earlier we plan, the more benefit we will have. Having a new lifestyle, the software industry should take steps to slow down or reduce the rapid pace of development, rather than thinking about the deadlines or the software releases. The developer should focus on the quality of the product. They should think for long-term success instead of delivering the deliverables in short time. Allocating a particular or a required amount of time for documentation and imposing standards on the structure will make sure that the efficient software products are delivered. Next is having a planning for change. As discussed earlier, a proper planning has to be done beforehand, assuming the changes can happen in the future. A proper documentation and review must be done in each phase of the product development cycle. And coming to the documentation, as I said, this documentation plays a major role, or it's very important in reducing the limits of the software aging. If it is not documented, then it is done. The product has to be documented properly. The documentation and the development should go hand in hand, as both are very important for the survival of the software. Coming to the conclusion, software aging is inevitable. As we have discussed in the previous slides, that even after following all the approaches, the software aging is inevitable. For example, reviews or the second opinions are done in the designing phase to bring out the issues that are missed by the original designers. But these reviewers are also human beings, and there is a possibility that these reviewers can also miss these things. So, but we as a developers need to be ready and prepare ourselves so that we can limit the effects caused by the software aging. And there should be a proper knowledge on software engineering. This is not just this is not about just coding. Software engineering, the phrase should mean something. It requires a lot of other qualities to be a professional software engineer. There has to be some professional standards and the standard education requirements that need to be followed. Though the software aging is inevitable, having proper planning and proper documentation and reviews, all these things together can limit the effects of software aging. And these are my references, and everything that I have discussed was from this paper.